Hello everyone. Bit of a disclaimer before I actually start explaining how to create this rounded rectangle mask material function is that by no means I consider myself an expert in this subject, but I'm currently learning to become more proficient in using game engines and especially the user interface side of game engines and real-time graphics with a heavy focus on materials, because I find it incredibly entertaining, incredibly rewarding, and also a very powerful approach. And I thought it would be nice for me to share what I'm learning, what I'm doing with the rest of you guys. So maybe it's gonna basically spark interest, or like gonna be useful for someone out there, and hopefully get some comments, or maybe have some discussions about what the same thing, like how the same thing can be achieved in a better, more efficient way. And so if you feel free, please let me know in the comment section about how I can improve it, or what kind of other considerations I can add to my efforts. Because at the end of the day, I'm also doing this to share knowledge, have discussions, and kind of put more structure into my training. So with that out of the way, let's go. Okay, so before we dive into Unreal Engine, I would like to clarify how one of the ways that we can use to create a rounded rectangle. And to represent that, I prepared this Desmos graphing calculator graph, and I'm using A and B as variables to control the size of our rectangle, and C as the rounding radius. And with this, we are going to achieve a rounded rectangle with a width of 20, with 2 times A plus C, and a length of 12 with B plus C, 2 times B plus C. So the first thing you need to understand is how to create a rectangle, and this equation that you see here gives you a rectangle with width of 8, since C is 0, width of 16, and a length of 8, so 2 times 4. So the second part is like, this gives you just hard edges, hard corners. It's a rectangle. So the approach that we have here to create rounded edges is to actually start by like putting circles at each corner of our rectangle. And to achieve that, you can use this equation number 7. As you can see, so there's a circle in each corner, like centered at each corner, and the radius is 2. So as you can see, minus 8 to 10. It's just defined by. So if I change this, you can see that the circles are actually getting bigger. Then following that, so the mentality that I have here is like, I would like to push these edges out by the radius, which is C, which is equals to 2 units here. And to achieve that is actually really easy. So just take the previous example, and instead of equals 0, just make it equals C. Here you can see it. And the last one to achieve the round rectangle is that instead of using this linear change here, I would like to use this quadrant here, this quadrant here, this quadrant here, and this quadrant here. And this basically comes from utilizing the circle equation, which is x squared plus y squared equals c squared in this case. And we just need to add like power 2 to each one of these entries, including both maxes and our output. And when you add this, voila, you have your rounded rectangle. So I'm just gonna disable this and this just to show you that we have a width of 20 and a length of 12, and our rounding radius is set to 2 units. Our radius is 2, as you can see, and it just happens in 2 for each of our corners. So if you change this, this is going to also push it out, because if you implement it like this in the Cartesian coordinate system, it also defines the size of your rectangle. But in Unreal Engine, we're going to use the UV coordinates, so this is not going to be a problem. So let's head back to Unreal Engine and dwell into Material Editor. Okay, so in Unreal Engine, I'm going to start by creating a material, and I'm just going to name it mtestui and save it. And inside the material, we are going to first change our material domain to user interface and the blend mode to masked. So just go ahead and save this. And the first thing I'm going to do is get the variables and prepare A, B, and C, and also the dimensions of our rectangle. So start by putting a vector 2 for your dimensions, and in this case I'm just going to use the width and length here that is on the previous slide to achieve demonstration. And I'm going to multiply this by 0.5 to get our half dimensions, and I'm just going to make it name declaration here, name it half dimensions. So the reason is like twofold. I'm just going to add a comment here and to show you what we're actually trying to achieve here. So our width was 2 times A plus C, and our length was 2 times B plus C. So we need to get to half anyways, but also since we are creating a symmetrical shape using the first quadrant and just copying it basically like copying its symmetric version into the other 3 quadrants. So we need to have half dimensions in order to adjust our UV scales that we're going to use in a moment. So that out of the way, we have our half dimensions. So now to achieve this, basically we're going backwards. We're just gonna subtract, so this our C. So just gonna add another variable, and let's say we're gonna round it by 50. And again, to make it easier, I'm just gonna add named route here. So this is our C now, and we're just gonna subtract this from that. There you go. And in order to achieve like both A and B and assign them a values, I need to separate this. So I'm just gonna break this vector 2 into R and G, well X and Y in this case. And our R is going to be RA, and our B is going to be the G here. And here you go. Let's put it kind of a little closer. I hate it when this breaks. Okay, so with that, we are basically all ready. So we have our A, B, and C, and also our half dimensions. I'm gonna change the color of this to something else so it's easier to see. Maybe something that we don't have here is like, yeah, orange maybe. There you go. And let's also change the background color of this to something a little bit, yeah, maybe a side. And so this is it. This is all we need for the variable side. And to continue from here on, so we are going to move on to the function that we were just working on in Desmos. So I'll just add a comment here, and I'll just make this a little wider, and I'm going to write that equation here down. So we are going to get the absolute value of, actually like this, of x minus a, or it's 0, plus maximum and absolute value of y minus b, or 0 equals c, and we are actually supposed to raise them to the power of 2, and here we go. So this is going to be the portion of our rounded rectangle where we're actually going to use the function. And in here, so we have to start by creating our Cartesian coordinate system first. And to achieve that, we are going to use a texture coordinate, not a sample. And so if you preview this, and more experienced people probably know about this, but the coordinate system, the UE space in Unreal Engine starts on top left from 0, 0 and goes to bottom right to 1, 1. So we need to change this into a coordinate system that starts at the center of the screen, or in this case our widget, and then just grows outwards. So to achieve that, we are going to use a constant bias scale. You can also just use like add and a multiply node, but I like this more because it's concise. So I'll just basically make this 0.5. So it's going to add 0.5 to all the coordinates. So now our 0, 0 is actually here. Sorry, and our 0, 0 became in this case, what happens? 0, so it's minus y, minus 0.5, minus 0.5, and we have 0.5, 0.5. And if I scale this to 2, now this actually, if I do this, it actually goes from, -1 to 1 in both axes. And following that, so now we need to multiply this with our half dimensions. I'll just put this up and I will bring out the half dimensions that we calculated here. So I'll just leave it like this. And now if you start a previewing node, you're going to see a sharper for quadrants here, because now it goes from our half dimensions minus half dimensions to plus half dimensions in this case, which is like minus 125 to 125 in both axes. And following this, so now we have both x and y available here in a vector 2 form. You can get equations, so if you feel like it, you can also work like separate here, like break them and then work on them individually. But if you take a look at it, actually the operations you do are exactly the same on both sides, so you can keep it as a vector 2 and just operate on that. And that's what I'm going to do because it's much easier to read that way. And I will start by taking the absolute of these values. So now we basically handle this portion of our equation, and then I'm gonna subtract our a and b, but before that I'm gonna get a, I'm gonna get b, and I'm gonna make a float 2, well, which is a vector 2 in this case, and I'm gonna subtract it from that, so I'll just move it a little bit closer. Here you go. Yeah, maybe here. So at this stage, this portion is completed on both sides. So then I'm going to add a maximum node and set it to 0. Let's see. Here you go. So now this is what you have. You actually separated the Cartesian system into 4 different areas, depending on your the values of x and y, and inside basically is the area. Like this black area is actually where we're targeting in reality, because this is the one that we will be using to draw our round rectangle. And after this, you're just gonna raise it to the power of 2. And yeah, for the left side, so this is it. Here we are done. Oh, actually no. So we need to also break this out, and so now we have individually both x and y and just add it to each other. And let's preview this. Here you go. Now we have this square in the middle, which depends on the base square basically that we were explaining before, which depends on your half dimensions and a and b. So the second part is the right side of your equation. So you're just gonna get c. This is quite actually easy, and just raise it to the power of 2. You might also just use multiply, like multiply c by itself, a and b by itself instead of power, because I believe power function of Unreal Engine is kind of using a bit more optimization maybe internal than just multiplying something by itself when you use the second exponential, like the value of 2 in the exponential field. So I would need to check the assembly code to be able to define whether power is like more cost intensive than just using multiply in this case. But yeah, if anybody knows that, or if you try that, please let me know in the comment section. And yeah, now we have also the right side. So how we are going to approach this is actually with an if node. So what we want to check is our b is going to be our c squared. So I will add 2 more constants here. So in reality, so when a is greater than b, it's going to be 0, because that's the area that's going to lie outside of our round rectangle. And when you are inside our rectangle, I'm just going to make it 1. So if we start previewing this right now, voila, you have your round rectangle. And let's say changing c at this stage, if I make it 100 for example, is going to define how rounded it is. And in this case, I mentioned before, our half dimension is 125. So if you just write 125, what you're going to get is actually a circle. So I'll just go back to 50 here in this case, and I'm going to stop previewing this. And yeah, just to show you, so this is going to be our opacity mask. You're already seeing that our round rectangle is here, and maybe just add like a, find like a warm color like this, and here you go. You can also use like an image here. Actually, you don't need to use a color, obviously, but yeah, this is on a hindsight how you can achieve a rounded rectangle. Let's change the color while I'm explaining that. And this is simply the material that you can use to achieve this. But you need to also understand that this equation requires, in the sense, the coordinates, the size, the dimensions of your rectangle. So if I set this to 500, for example, our aspect ratio is going to change, and you can actually see that the roundness actually changes. So this is not a circle anymore, it's an ellipse. So to fix that, you need to, where it is, change the preview size. So yeah, if you put it into here, yeah, you can see now it's also, if I can zoom here, yeah, you can see now it is actually correct. So this is something that probably when you create your widget, you need to add this as a dynamic material, and just bind the size of your widget to these variables here. Okay, so in order to make it a bit more useful, I'm going to create a material function inside my content functions folder, and I'm going to go to materials, material function, and name it rounded rectangle mask. Save it and open it. So I'm just going to go back to my previous material, going to copy everything except the color and paste it here. And for now, I'm just going to connect this if node to the output result and change it to a primitive plane. Set my field of view to 50 to see it a bit more better, and here you go. So now the reason why this is looking a little bit skewed is because we set it to 500 there, but this is actual 1-to-1 aspect ratio. So here you go, when you go, here you go, you have your proper rounded rectangle again. And to make it a proper function, first I'm gonna actually make a little bit more space here, and I'm gonna move this up, and I'm gonna start by adding a function input. I'm gonna make it vector2. I'm gonna use preview as default and connect this to the multiply. So again, you're getting the same thing. So this is the first step, and the second step is I'm actually going to address something that this current implementation has, which is this radius here. So when it goes to a value higher than your half dimensions, which is 125 here, it kind of creates a weird, like this diamond-like shape. So sometimes this might, your designer maybe wants that, but okay, I would say that, yeah, oftentimes you don't want this to happen, because the maximum you can clip is actually the minimum between the x and y of your half dimensions. So I'm just going to implement this as a switch to make it a bit more convenient. So you can just basically flip a switch, and depending on the situation you can have a different approach. In order to do this, I'm first going to disconnect this, kind of open up some space here, and put my subtract here. For some reason, like, it always does this, but yeah, I really don't like it. The orientation just changes. And I'm going to leave it at 225 so you can actually see what's happening. And I'm going to do this, and eventually I still need to subtract c from this value here. And this one, I'm going to make the function input of a scalar, going to name it radius, use preview, and I'm actually going to deal with the sort priority later. Here you go. So now we have this, and I'm also going to add a static bool to control whether we want it or not. And I'm going to also make this a function input, and I'm going to name this clip radius. From here we want a static switch at true. This is going to control our value, and yeah, maybe put this below, just higher up. So when this is basically false, what we are going to do is we are directly going to pass it. We are not going to do anything. But when this is true, we want to clip this based on our half dimensions. But before that, we need to break this and get a minimum between this R and G, which is our X and Y, aka width and length, and compare our scalar value with this again to get the minimum between these two. So let's say if your half dimension is 125, and in this case when it's 250, we want it to be clamped to 150, not get 250. But if this value is false, we're just going to basically pass 250 as it is, and we're just going to connect it here. And I think I'm gonna do it, arrange it a little bit better. I will push this aside, and here you go. Yeah, I'm actually not liking this. Yeah, maybe in the middle is better. And then this result is going to connect to our C, and now you can already see the previous diamond implementation. I will just set this to top, push it output, maybe bring it a little more. Here you go. And yeah, maybe like this. Yeah, this is actually grinding my gears, so I'm just gonna select this to arrange it all and possibly add maybe here, and possibly push it a little bit further. Here you go. Yes, yeah, that's enough. Pixel perfection. So this is right now giving you the control over that. So if you select this, you can say you're just getting 125, which leads to excuse me, leading to the perfect circle. And if it's less than that, you still have the ability to just have the roundness. And similar when it's false, basically you're not clipping anything. But if you put it to 255, so you get that diamond shape again, clip it back, you have the circle. So I'm just gonna put it back to 54 now. And by default, I'm gonna leave it as true. And now this part is done, and we're going down. So I would like to add a little bit more functionality to the UVs. So expose it, so we can actually achieve a bit more detailed effects with it, and not just a single rounded rectangle. And similar to what we have done, I'm going to add a function input, name it UVs. I'm going to make this vector 2 and use the preview as default. And yeah, just directly connect it. And yeah, in reality, that's all. Like, that's all what you need to do in the function here. And yeah, you're actually good to go with this. So apply and save, and go to your test UI. Yeah, well, I already disconnected this, so I'll just move this out of the way. And what I'm gonna do is gonna come here. I'm gonna add a material function call. It already detected round rectangle mask. I'm gonna connect it to the opacity. It's gonna give me an error because I think I forgot to arrange things. So first things first, UVs using default is going to be 0. This in needs to be the dimensions, and it's gonna be sort prior to 1. And the radius is going to be sort priority 2. And clip radius, yeah, this is one I forgot. It's actually not clip radius. Yeah, clip radius, and this is going to be the third. This is the last one. Okay, save it again, and go to your test UI. Now you can see everything is working, but you're actually not seeing the TIG. If I'm just gonna set the border to triangle, here you go. You still have the same thing, but now you can just control everything from here. So I'll just copy from this previous one here. So my dimensions were actually, let's say that to 500. Here you go. It's working. And I'm just gonna add another scalar to set it to 50. Here you go. Set it to 200. still working, and set it to maximum. It's clipping because our clipping is actually, actually even if I set this to 500, you're going to still see that. But I'm gonna add a static bool here. Okay, when it's false, you get this right. Sorry, when it's true, you get. Yeah, that's good. Just make it maybe again 100. Sorry, 10, 100. And yeah, you're good. So one thing that I should also probably show you, I'm just going to set it to 1:1 before that. The UVs, as I mentioned, so now you can also do things like add your texture coordinates and tile it maybe 8 times in both axes, then get the fraction. So this gives you just kind of like a checkerboard. Stop programming, align it, and if you give this as your UVs, you can also get this kind of shapes. And yeah, in a way you can use this to have different effects, different like kind of like a halftone effect. If I also like to make it a perfect circle, you can see by utilizing this, not just a single rounded background, but a little bit more than that. There you go. And yeah, to be honest, I felt really like enjoyed myself when I was working on this, and I kind of see a handful of places I can use this when I'm working on some other project or some other UI elements. But yeah, this is all, folks. Happy materials, happy UI, happy coding.